Okay, so in number one, you're given that you want to find the equation of the line that is parallel to this line, and that line you're interested in passes through the point 3, -1. And you want to write the equation in slope-intercept form. Okay, so you have to remember that these two lines here, the one where this equation is given and the other one where all you're told is a point on that line, those two lines are parallel. So you have to remember that parallel lines have the same slope. All right, so in number one, this line here that is parallel to the line that contains this point, remember they're parallel, so they have the same slope. So the slope of this line, and notice that this equation is in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where the slope is the coefficient of x. And so in this case, you'll notice that the coefficient of x here is 2/3. So the slope of this line is 2/3. So that means that the slope of the line that goes to this point is also 2/3. And so if you're going to write an equation of a line, knowing the point and knowing the slope is sufficient. You can then use point slope form. So this is going to be your work. So this is the work here. So that's the work I needed you to show. So point slope form. And so remember, point slope form is y minus y1 equals the slope times x minus x1. And so you know the slope of this line, it's 2/3 because it's parallel to this line, which has slope 2/3. And you have this point here, so we'll call this x1, y1. So we're going to substitute into this formula. So y subtract -1 equals the slope, which is 2/3, times x subtract x1, which is 3. And then let's go ahead and simplify this, and we're going to go ahead and distribute over here. So this becomes y plus 1, because y subtract -1 is the same thing as saying y plus 1, equals, and then 2/3 times x is 2/3 x, that's a 3, and then 2/3 times a -3, so let's look at that. So make sure you know how to handle multiplying fractions. And I'm going to write -3 as -3 divided by 1. Notice I can reduce first if I wanted to, or I can multiply and then reduce. It does not matter. If you multiply and reduce, you would get -6, because -2 times -3 is -6, divided by 3 times 1 is 3, so that will be -2. If you had reduced first, 3 divided by 3 is 1, -3 divided by 3 is a -1, and notice 2 times -1 is a -2, 1 times 1 is 1, and that is just -2. So in either way, you get -2. So this right here is going to be -2. Then remember, you want to put this in slope-intercept form, so we got to get y by itself. So I'm going to subtract 1 from both sides. I'm aligning my like terms. 1 and a -1 is 0, so this becomes y equals 2/3 x minus 3. And so that's the equation of that line that contains this point and is parallel to this line. And what I want to do is, before we go into number 2, is actually look at the graphs of these two to kind of see that, hey, they are parallel. So let's look at the first one. So this one, so I'm going to write this here, y equals 2/3 x minus 1. So this line here that's in slope-intercept form, remember, if it's in slope-intercept form and you want to graph it, you can use the slope and the y-intercept to do this. So the slope of this line is 2/3, and the y-intercept, the point where the graph crosses the y-axis, is going to be -1. And so what we have is this. So we're gonna plot the y-intercept first. So that's going to be -1. So that's where the graph right here. So that's where the graph's going to cross the y-axis. So if you label it, that's going to be 0, -1. The slope is 2/3. So remember, the slope is rise over run, and both of those are positive. So meaning that if I do the rise first from this point that's on the line, I'm going to go up 2. because it's positive. So I'm right here. And then I'm going to go to the right 3 because that's positive. So remember, run means left, right. Rise means up, down. So since they're both positive, we're going to go up and to the right. Okay? So we're going to go up 2 and then to the right 3. So right here. So that's the point here, 3, 1. And so if I graph that line right here, so this is the, let me go ahead and draw this. All right, so right here, that's the line y equals 2/3 x minus 1. Now let's look at the other equation that we just found. So we're saying that this line and this line are parallel, right? So let's look at this one. So this one is y equals 2/3 x minus 3. All right, and hopefully you notice that they have to be parallel, right? Because they have the same slope. But let's just look at the graph to verify that that's the case. So my y-intercept this time is -3, and my slope, it has to be the same because they're parallel, right? So here I'm going to plot the point, the y. Well, remember the y-intercept -3 means that's where the graph crosses the y-axis. So that's going to be here, right here. So that's the point 0, -3. And then we're going to go up 2 to the right 3. So up 2, 1, 2, and then to the right 3, 1, 2, 3. And I'm kind of overlapping some stuff here. So, but that's going to be the point 3, -1, right here. 3, -1. And if I graph those, you'll notice they are parallel, right? So if we look at it, all right. So notice that they are parallel. So these lines have the same slope, and they have different y-intercepts. So they are going to be parallel. All right. So that is number 1. So that's the work for number 1 here. Okay. Now let's look at number 2. So number 2, you're told that this time this line here is perpendicular. So notice the word perpendicular here. Perpendicular to the line that contains this point. All right, so remember, perpendicular lines have slopes that are negative reciprocals of each other. So number 2, we're given this line, y equals -5/7 x plus 3, and it is perpendicular, that line here is perpendicular to this line that passes through this point. And that's the point -2, 5. So if I'm going to find the equation of this line that contains this point and is perpendicular to this line, I need to know the slope. I know the point, I just don't know the slope. Well, we know that these two lines are perpendicular. And we know that this line is in slope-intercept form. So that means that the slope of that line is -5/7. So that means that this line here, which is perpendicular to this line, is going to have a slope that's a negative reciprocal of this line, the slope of this line. And so if this is -5/7, then that means that this is going to be a positive 7/5. You take the reciprocal. All right, and so now we're going to go ahead and we're going to use point-slope form. So here's your work. So point-slope form is what we're going to use. And so I get y minus y1 equals the slope times x minus x1. And so here's going to be my x1, my y1. So I get y minus 5 equals the slope, which is 7/5, times x minus x1, which is -2. So I get y minus 5 equals 7/5 times, I'm going to go ahead and simplify x subtract -2 is x plus 2. And then I'm going to go ahead and distribute. So I get y minus 5 equals 7/5 x. And then 7/5 times 2. So remember, you got to make sure you do this correctly. 7/5 times 2. And that's 2 divided by 1. I cannot reduce. I'm just going to go ahead and multiply the numerators and the denominators together. So 7 times 2 is 14. 5 times 1 is 5. So you have 14/5. So it'll be plus 14/5. And then all I need to do now is add 5 to both sides because I want to write this in slope-intercept form. All right, so I'm going to go ahead and add 5 to both sides, combining like terms. I get y equals 7 fifths x plus, and then all I need to do is add 14 fifths plus 5. And if I do it by paper, just to remind you how to do this, if I do it by by hand, 14 fifths plus 5 divided by 1, the LCD is 5. So I need to write 2 equivalent fractions with 5 as a denominator. So 14 fifths is equivalent to itself, and then 5 is equivalent to what number divided by 5? Well, you can guess at this very easily, and that's going to be 25, right? But what some students do is they'll actually say, well, I need this right here to be a 5. I have this to be a 1. So I got to think 1 times what number is 5? Well, that's going to be 5. But what I do to the denominator, I do to the numerator. So 5 times 5 is 25. And so this becomes 39 fifths. Now, if you use your calculator, just to remind you, that's what you would do. So these are both positive, so it makes things a little bit easier for you in the calculator. But what you're going to do is let's see. All right, so you're going to say positive 14 fifths, so 14 fifths, 14 divided by 5 plus 5 equals this decimal, this rational number. And I'm going to convert that to a mixed number, right? But before we go on, I just want to remind you. So this one's easy to think about. So 7.8 really means 7 and 8/10. And if I reduce 8/10, that's 4 fifths. So that's really 7 and 4 fifths. So there's my mixed number. So when I do this right here, so to convert this to a mixed number using your calculator, so remember, see this PRB right below above that in blue is fractions, decimal, decimal, fraction. So F to D, D to F. So, but you have to get there using the second function. So second, and then PRB. So you get that, press equal, and you get 7 and 4 fifths. All right, and then, but you gotta rewrite this as an improper fraction to kind of keep it consistent here. And so 5 times 7 is 35, and then 35 plus 4 is 39. So you get 39 fifths. And that is it. So that is the equation of the line. The equation of the line that contains this point and is perpendicular to this line. Okay. All right. So let's see now. Although the y-intercept is not a whole number, it's not an integer. Let's see if we can go ahead and kind of look at the graph. Let's see what that looks like, just to kind of show you. So it's going to be an estimate when I put this here, because the y-intercept is not it's not an integer. But 39 fifths, remember we said was I didn't write it here. 39 fifths is 7 and 4 fifths. So that's where the graph crosses the y-axis, and I may not have enough room, but let's just try and see what we can do. So let's first of all graph this one. So when I graph this one, so y equals negative 5/7 x plus 3. So graphing this one's easy because the y-intercept is an integer, so I can easily plot it. So the slope is negative 5/7, and the y-intercept is 3. So this is where the graph is going to cross the y-axis, and from that point, I'm going to use the slope to find the other point. So my rise is negative 5, and my run's a positive 3. So I'm going to go down 5, 1, 2, 3, 4, 5, and then to the right 7. 1, 2, 3, 4, 5, 6, 7. All right. And so this point here is 7, negative 2. All right, so let me just go ahead, and the y-intercept here is 0, 3. All right, so I'm going to go ahead and plot those. I'll graph that line. And when I do that, I'm going to get this. All right, so hopefully this line here is going to be perpendicular to this line. So remember, perpendicular lines intersect at right angles at 90 degrees. So hopefully it'll look like it does. But I am going to have to estimate where this is. So 39 fifths, remember, is 7 and 4 fifths. So So this is 7 4/5 is about here, let's say. And it's going to be a struggle to use the slope here. So the slope is 7/5. So I don't have enough room, so I'm going to have to estimate. So 7/5. So let's just do this. So what I'm going to do is this 4 4/5, which is, I'm sorry, the 7 4/5, which is 7.8. I'm going to add, so remember I'm going up 7, right? So I'm going to add 7. So plus 7, and that's going to give me 14.8. So I'm going to go up 7, so that's going to be at 14.8. So let's see, that's 12, 13, 14, 15. So that's about here, let's say. Okay? And then from here, I'm going to go to the right 5. So let's see, 1, 2, 3, 4, 5. So let me estimate where that is. Let's see, let's do it again. 1, 2, 3, 4, 5. So that's about here. Okay. So let's see. All right. So there's my y-intercept. There's another point right here. So when I graph this, hopefully it'll look like it intersects at a right angle. All right. So you see this right here? So it does look kind of like it intersects at a right angle, right? So those are the two lines you found. So this one is y equals right here, 7/5 x plus 39/5. And then this one is y equals negative 5/7 x plus 3. All right, so just to give you an idea what this looks like graphically. Now this was harder to graph because this y-intercept was not an integer. So you kind of had to be careful how far you went up. And all I did was I took this y-intercept right here, which was 7.8, 7 8/10, and I added 7 because I need to go up 7, right? So going up 7 means add 7. And so that means that I'm at 14.8, but then from that point I had to go to the right 5 units. So 1, 2, 3, 4, 5, and so that's where I'm at. And then I just connect the points I draw a line through those points, and notice it looks like it's a right angle. All right. Okay, so that is, well, but right here, just to let you know, so that this is the work you have to show. So there's the work for number 1, there's the work for number 2, and then these are your equations in slope-intercept form. All right, so that is the key to the 2 problems here on finding the equation of a line. One's parallel and the other one's perpendicular.